This video will explain how to find the differentiation of inverse trigonometric functions. So this is the differentiation formula for the inverse trigonometric functions. So the derivative of the arcsine of x is equals to 1 over square root of 1 minus x squared. And then the derivative of arccosecant of x is equals to the negative of 1 over square root of 1 minus x squared. So you can see here it's almost the same, but for the derivative of arccosecant of x we just add negative at the front. Okay, and then for the derivative of arctangent of x is equals to 1 over 1 plus x squared, and the derivative of arcsecant of x is equals to 1 over modulus of x times with the square root of x squared minus 1. And the derivative of arccotangent is equals to the negative of 1 over 1 plus x squared. And the last one is the derivative of cosecant inverse of x is equals to negative 1 over modulus of x times with x squared minus 1. So it's the same where the derivative of secant and cosecant, this one just add negative. Okay, and same goes with the arctangent of x and the arccotangent of x, where we just have to add negative to this answer. Okay, so this one shows you the general of the differentiation formula for the inverse trigonometric function. So given u here is a function of x. So if u is a function of x, then when you have to find the derivative of the arcsine, what you need, you will get 1 over square root of 1 minus u square times with, you have to differentiate the u here with respect to x. Same goes with the arccosine of u, where the derivative of the arccosine of u is equals to the negative 1 over square root 1 minus u square. Then you have to find the derivative of u with respect to x. Same goes with the rest of the functions. Okay, now let's try this example 1. Find the derivative of the following functions with respect to x. So here we have 4 questions. Okay, let's try this out. Now let us try solve the first question. So given the question is y equals to the arccos of 4x. So we will use this formula in order to solve this derivative. So now what we need to find is, we have to find the derivative of this. So it will be dy over dx. So why we have to use dy over dx? Because our y is in terms of x. So that's why it will be dy over dx. So let's say your question is y equals to arccos of 4u. So it will be dy over du because our y is in terms of u. So, okay, so now let us go back to our questions. So here we have our arccos, where our arccos is minus 1 over square root of 1 minus u, where our u is equals to 4x. So just substitute our u with 4x, and don't forget to put square. So the whole 4x will be squared. Okay, next is we have to find the derivative of 4x. So it will be d over dx of 4x. So now we can solve this. So we simplify this derivative, it will be, so I just rewrite back. So it will be 1 minus 16x squared times with 4. Because the derivative of 4x would be equals to 4. So I would just rewrite this. So this would be the answer for this question. which is negative 4 over 1 minus 16x squared square root. Okay, now let us try the second question. You can try this out. Okay, pause the video and check the answer after this. Okay, so now we have to find the derivative of this. It would be dy over dx equals to, so the arc cosecant would be this formula. So we just rewrite this. So don't forget our u here is not u. Our u is represented as x squared plus 1. So just rewrite our u with x squared plus 1. Please don't write it as u, because our u in this question is represented as x squared plus 1. So now it would be negative 1 over modulus of u, which is x squared plus 1, times with square root of x squared plus 1 square minus 1. Okay, times with the derivative of u, where u is x squared plus 1. So it will be d over dx x squared plus 1. So we simplify this. You can either expand this or you can just remain it like this. Times with the derivative of x squared plus 1 would be equals to 2x. So now that would be our answer, which is this. For the next question, to find the derivative, it would be dy over dx. And the derivative of arctangent would be equals to this, 1 over 1 plus u, where our u is this quotient. So we just rewrite this, 1 plus 4x over 1 minus 4x squared. Then don't forget to find the derivative of this quotient. So it would be d over dx of 1 plus 4x over 1 minus 4x. So the next step is to find this derivative, which involve the quotient rule. So first, let us solve this quotient. 1 plus 4x over 1 minus 4x. So if you still remember, for the quotient rule, the formula would be d over dx of u over v would be equals to v du over dx minus u dv over dx over v squared. So our numerator would be always equals to u, and the denominator will always be v. So our u is equals to 1 plus 4x. So our du over dx would be equals to 4, and our v is equals to 1 minus 4x. So dv over dx would be negative 4. So now we can substitute into the formula, where it will be v, which is 1 minus 4x, times with du over dx, which is 4, minus with u, 1 plus 4x, times with dv over dx, which is negative 4, divided by v squared, which is 1 minus 4x squared. So now simplify this, you will get 4 minus 16x, and here it will be plus 4 and plus 16x. So simplify this one would be removed. So it will be 8 over 1 minus 4x squared. So now we have solved our quotient part here. So what we can do next is just substitute back into dy over dx, where this would be equals to 1 over 1 plus 4x over 1 minus 4x squared times with 8 over 1 minus 4x squared. So this is the last question. So you can notice here, this is the product of two functions, which is x and arcsine of x, plus with square root of 1 minus x squared. So for this first term here, we need to use the product rule in order to solve this derivative. So what we can do, first of all, just find the dy over dx equals to d over dx of x arcsine of x plus with d over dx. So I just simplify this into, I just rewrite this into 1 minus x squared to the power of half. Okay, first I will solve the first term here, where this would be d over dx arcsine of x, where our u would be our x and v would be the arcsine of x. So using the product rule, it would be u dv dx. So the derivative of arcsine would be 1 over square root of 1 minus x squared. Okay, and then the derivative of x would be equals to 1, plus with v du dx. So dx over dx would be 1. So this would be our answer for the derivative of x times with arcsine of x. So simplifying this, it would be x over 1 minus x squared plus arcsine of x. So now we have solved the first term. So we just rewrite into this dy over dx. So here it will be x over square root of 1 minus x squared plus arcsine of x. Now we solve the second term here. Okay, so to find the derivative of this, it will be 1 over 2 1 minus x squared to the power of negative half. And then don't forget to find the derivative of the 1 minus x squared. So it will be negative 2x. So simplifying this, it would be x over 1 minus x squared. So I will just rewrite these two terms. Okay, and then here it would be minus with x over 1 minus x squared. So we can cancel these two. So your final answer would be arcsine of x. So that's all for the differentiation of inverse trigonometric function.